All right, so here we go.
The tangent inverse.
So this is worksheet 6.1, number 7. So it says a 0.34 kilogram particle. So the mass of the thing is 0.34 kilograms. It moves in an xy plane, and then it gives you two functions. It gives you the horizontal position as a function of time. So it's negative 15 plus 2t minus 4t cubed. And the vertical position as a function of time is 25 plus 7t minus 9t squared, with x and y in meters and t in seconds. And then it says at t equals 0.7 seconds, it wants to know the magnitude and angle of the net force on the particle and the angle of the particle's direction of travel. Okay, so this is all of our given information. Is everybody good here?
Yes.
All right, so the first question is about net force. So we've learned in this class basically two ways to deal with net force, right? Hence, net force equals net force, right? So one way to find net force would be to add up all of our forces. Is that going to help me here? No, because it doesn't say boo about what forces are acting on the thing, right? So the only other way we can possibly find net force is to do mass times acceleration, right? So I see the mass, which makes me happy, but I do not see the acceleration. So, thoughts about how to find the acceleration, you guys? Sure, get me started, Jake. All right, sorry, Zach.
You take the derivative twice of each component.
Yeah, you guys agree with that? Okay, cool. So let's do that. So if you do this, we find out that our Vx as a function of time is going to be, what, 2 minus 12t squared? And our Vy as a function of time is going to be 7 minus 18t. Cool? Everybody good with that, just by taking derivatives?
Yep.
So this is dx dt, and this is dy dt, right? Everybody good? All right, so now I'm going to take another derivative to find my acceleration. Lately I've been wanting to pluralize the word acceleration that way, and that's the first time I've actually done it. I enjoyed it. All right, so our acceleration then as a function of time, just by taking another derivative, is going to end up being, what, negative 24t? And our vertical acceleration as a function of time is going to end up being negative 18, right? Cool? No, that's not at all a valid. Did you just pull out a dictionary? That's amazing. All right. So let me pause there. Did I lose anybody? All right. So at this point, we've got two choices. Shh. At this point, we've got two choices. We can either find our overall acceleration and then multiply by mass, or we can multiply by mass now and find my net horizontal force, my net vertical force, and then put them back together. All right? So let's do the first option. So what that means then is this. Acceleration is, well, let's see, our x component is negative 24, right? T. Our y component is negative 18. So here's my acceleration, right? I guess we might as well just plug in the time, right? Does that seem good? So let me scroll down a scotch. So at t equals 0.7 seconds, let's see, my ax is going to be, what's 0.7 times 24? 16.8, thank you. Meters per second squared, don't forget the negative. Your ay, not drawn to scale, is negative 18 meters a second squared. So you can find your acceleration just by doing some Pythagorean theorem, yes? So that gives you a number, multiply it by the mass, and that gives you your net force. Good? Is it okay if I stop there for how to find the magnitude of the net force? All right, now let's talk about the direction of the net force. And this is huge, and it's a big point in this section. without exception, what's the relationship between the direction of acceleration and the direction of net force? They're the same. Okay? That's what Newton's second law tells us. Net force is a vector, and it's equal to the mass, which is a scalar, times the acceleration, which is a vector. So the direction of your net force is always the same as the direction of your acceleration. So if I want to find the direction of the net force, I can just find the direction of the acceleration. Okay? And again, I think the answer key that you guys had a typo, and I'll fix it by next year. But so I think it gave the angle below the positive x-axis, and it really should have been below the negative x-axis. Cool? The other options I could have done 180 minus whatever that answer was. All right. Everybody good with A? All right. B says, and this is another problem. I don't know if you guys remember, there was a problem when we did two-dimensional motion that you guys struggled with that had the same question. It says, what's the angle of the particle's direction of travel? So up here at the top of the screen, I got a bunch of information here. I got information about position as a function of time. I've got information about velocity as a function of time. And I've got information about acceleration as a function of time. Which of those three functions is the one I want to look at to determine the direction of motion? What do you got, Justin?
Velocity.
The velocity. Does that make sense? Because remember, velocity is speed and direction. Okay? So all you need to do part B is plug in 0.7 to these two velocity functions. And that'll give you your Vx and your Vy, and then find your velocity vector. Carla.
Could you not use acceleration?
You could not. So remember, the direction of the acceleration vector is the same as the direction of the net force vector. Yes?
So is that what was wrong with the answer key? That you used
I
acceleration?
think the answer for part B was right. Was it not?
Because I used acceleration and
Ooh, I don't know. Let's do it. I hope I didn't make a mistake, because that never happens. All right. Oh, shoot, I needed that. Here.
Bless you.
Bless you.
Bless you.
No, you could well be right. I thought I fixed all my mistakes last year, but there were some issues with Microsoft Word and my saving process. Okay, so what we want to do is this. We want to find the Vx as a function of time. So if you plug in 0.7 seconds, what does that Vx give you? Does anybody know? Let's figure this out real quick. So 2 minus 12 times 0.49 is negative 3.88 meters a second. And your Vy is 7 minus 18 times 0.7. That gives you negative 5.6 meters a second squared. So the velocity should have been, what did we want? Just the direction? So all I need is the angle, right?
Yeah.
So this angle, if you figure it out, inverse tangent of 5.6 divided by 3.88, 55.3 degrees below the negative x-axis, I guess is how you'd say that.
But I'm just confused because when I put in, so I had the,
Hang on, let me see what the answer was real quick. Was that the answer?
I mean, that's a complement angle, so, right?
Are you talking about part A or part B?
Wait, I'm confused.
I think we all are. I'm doing part B right now. So part B, it looks like the answer's good.
Okay, yeah. I'm sorry.
Maybe minus some rounding
Wait,
issues.
so
So part A is all about acceleration and net force.
okay. So
Yeah, that's
what
nice.
was the angle for A?
So part A asks for the angle of the net force.
Yeah.
And what I was hoping that you guys got out of my conversation about it was that the direction of the net force is the same as the direction of the acceleration.
Okay. That's what I thought I had asked that before. And you
Okay,
said
except I was talking about B,
Okay, so you're talking
and you were asking about A.
Okay, yeah.
So we were on different
Okay,
pages.
sorry.
All right, so is everybody happy now?
Yes. Sure.
We good? Okay, cool. So that's number 7.
I was happy previously. I'm still happy now.
Previously, in Josh's life.